So let me tell you about a fascinating story about how the Allies helped to win World War II by using decoys and deception. And don't worry, I'll tie this back to AppSec in a moment. But first, check this out.
Remember those aggressor tanks that our friend Lieutenant Vieta told us had just moved into position? They have been known to fool an observer from as little as 50 yards away. Such equipment, combined with a few real tanks, gives the aggressor the appearance of a strong armored force at a fraction of the cost in men, material, and time. Light and compact, this equipment can be shipped around the country to where it's needed with a minimum of effort. A few minutes at the end of this air hose, and the limp bundle becomes a 2-ton truck. Besides tanks and trucks, the aggressor pneumatic equipment also includes artillery. And speaking of artillery, here is some more aggressor equipment that adds to the realism. Sound and flash simulators. They give our forward observers a real target to look for. From a distance, when the pneumatic gun position fires, it could be the real thing. And when these battle noise simulators contribute their din to the maneuver area, you have the closest thing to combat without anybody getting hurt.
Isn't that just crazy? So before the invasion of Normandy on D-Day, the Allies needed to spread out the Axis frontline troops and divert them away from the invasion. To confuse the Nazis, they made it appear like a large army led by General Patton was preparing to invade Calais. They had faked an entire army using inflatable tanks, trucks, artillery, and even watercraft and airplanes. This was all part of Operation Fortitude. But it didn't end there. As they were crossing the channel on D-Day, there was a huge airborne deception plan that included dropping metal strips to confuse German radar, and even the dropping of explosive-filled dolls that looked like an invasion of paratroopers were happening hundreds of miles away from the real objective. What was kind of cool was when the dummies hit the ground, they exploded, making it look like the parachutes were abandoned and the troops had already moved on. It diverted huge resources away from the real landing site. And for over 7 weeks after the invasion, constant deception plans had Hitler holding back troops up north, as he still believed the real invasion force was going to come from Calais. This led to the successful foothold that the Allies needed to retake Europe. By that time, they had too many troops on the ground, and the war had shifted. But what does any of this have to do with AppSec? Traditionally, when it comes to cybersecurity, we always hear about how much more difficult it is to be on blue team, having to defend every possible attack vector, whereas our adversaries only have to find one way in. Well, I propose we shift that back to the benefit of the defenders. Alongside proper security engineering that should always be taking place, there is value in building decoys and deception into your apps. Confuse your adversaries and inhibit their abilities to conduct accurate assessments while misleading their efforts to make it harder for them to attack you. More importantly, help your ops team to know earlier in the attack chain when your apps are being reconned and exploited, and offer them operational insights and attribution capabilities so that they can focus on the attacks that really matter. Let me show you how, using Honeytokens. Okay, so the first thing an attacker is going to do is recon your app. They're going to scan your server, enumerate your ports, try to detect what's running where. So much of this is automated, and honestly, it's not that exciting. Many times there isn't even a human conducting this, so don't fret too much about it. But if you want to, check out tools like Port Spoof that have the ability to trick tools like Nmap into seeing ports that aren't actually open. They even go so far as to show the fingerprint signature so it looks like a valid service is there. And that makes it much more difficult for attackers as they start having to actually enumerate those ports and start trying to figure out what services are running there. But that's not what I'm talking about here. One interesting recon tactic that hackers like to use is to check out the robots.txt and enumerate all the pages with the disallow directive. This directive is designed to help prevent crawlers from overloading your servers and indexing areas it's not supposed to. But attackers see that as the perfect place to start their recon. If you don't want something indexed, they think it might be something important to them. And, well, we can use that to our advantage. Place a disallow directive in your robots.txt. Set it to a URL that seems interesting, like /admin-config or maybe setup app, and watch for it. Anytime you see that URL hit, you know someone is enumerating your server. Even better, set up a valid route, so instead of generating a 404 error, you can actually collect their browser, OS, and geolocation information, which you can then shunt into your security logs for investigation later. Then redirect them back to the main app, and they won't even know what's happening. But now you have an early warning signal that someone's rattling the cages. Now a tip. Check out things like Daniel Mesler's sec list and make sure whatever URL you're putting in the disallow directive isn't exposed in the common word lists. Most attackers use directory brute forcing as part of their enumeration, and you really don't want to report every scan of your app. Well, or maybe you do, in which case just check the word list and make sure you pick something unique and not normal. As an example, I wouldn't use the /admin as a deceptive URL. It's just too common. The trick here is to be able to signal when someone is purposely going against your disallowed directive. You can't guarantee that with common endpoints. Personally, one of my favorites was a hidden GUID-based URL that looked like an SRE metrics tracking endpoint. It was actually used as part of an attribution in a real attack by an insider at one of my orgs. Of course, your mileage may vary. Since we're talking about recon and humans reading stuff, let's move on to another way that we can trip up attackers. Okay, so some Recon 101. Hackers are being trained to always look at the source HTML, to look for interesting stuff in comments, things like variable names and URLs and interesting scripts. So let's help them out with that. Leave an interesting comment in your code, something that looks like a dev has forgotten to remove something important, like a link in an internal part of an app that might have been interesting that's hidden from the nav menu. Of course, that link doesn't have to actually exist. Or maybe it should, so that you can then collect the attacker's information, report it to your security logs, and then redirect them. No normal user will conduct this activity. It's a high fidelity signal that someone is looking deeper into your code than they probably should be. But maybe we need to be sure. Let's go deeper and see how we can detect when an attacker is trying to exploit our app. So a common attack pattern when trying to exploit a web app is through parameter tampering. When an attacker sees an interesting parameter available in a request, they will traditionally try to alter it to change the app's behavior. Tools hackers like to use like Burp Suite and OWASP Zap were designed to help with this. So let's leverage that to detect such attacks. Create a fake parameter that seems genuine but has no business impact on the behavior of the request. I like to use parameters like dev equals no or admin equals false because they attract attackers to want to change the parameter state to see how things will function. Because they're not real parameters, you can easily detect the change state and alert on such behavior. This is a really high signal of suspicious behavior and is something that should be looked at by your ops group. You don't have to do this just on requests. Consider doing this on posts as well, using hidden parameters in forums. Even better, in either state, consider shunting the response into an altered state so that the attacker thinks that things are changing. As an example, you could use a false flag with an admin parameter and render out a deceptive page which makes them think that they manipulated the business logic and caused an error. This helps to slow down the attacker by forcing them to investigate in the issue deeper, even though there's no real impact to your application. You'd be surprised how much time an attacker will waste trying to dig deeper into a randomized fake stack trace. Trust me, I've seen it. I've annoyed more than one hacker trying template injection on a critical app that doesn't even use templates, using deceptive parameters and decoy error pages. Okay, so let's go back to the hacker playbook. Standard operating procedures during recon is to always check session cookies. There are plenty of great examples of session hijacking by manipulating cookies in this way. So let's turn the tables and set up a strategy to detect when attackers have their hands in the cookie jar, so to speak. You don't want to actually tamper with real session cookies. It's too important of a function to want to add deceptive code that could add fragility to such an important underlying component of your app. But a fake cookie that is used in conjunction is all fair game. So create a cookie that seems real and important, like SID or SID token, CF token, auth level, whatever. You get the idea. Something that looks tasty and that could be altered. Make it a little bit harder and base64 encode it. Trust me, all but the most junior attackers will see through that and can easily alter the cookie and fire it back to the server. Of course, on the server side, if the cookie's been tampered with in any way, you'll be able to see that as suspicious behavior and can trigger an intrusion detection alarm. Which gets me to a side point. Talk to your ops team to understand how they monitor for security events. Work with their logging system to ensure that all these type of events can be shunted properly into their SIM, SOAR, or SOC. Make sure you keep a copy of the security events in your own logs, but play nice and work with your ops team so that they can correlate all this suspicious activity. Make sure you use global timestamps and a logging format that can easily be ingested and searched. Okay, back to making the red team's job more stressful. So every great hacker methodology for breaking web apps includes directory enumeration. Tools like Dirbuster, FUF, and AMAS are designed to brute force web apps in search of interesting endpoints. Basically, it's nothing more than hammering your server with web requests against a word list looking for URLs that return data. It's an unfortunate annoyance, as many hackers don't care that this sort of recon could cause service disruption when done incorrectly. And since most apps don't even have robust throttling as part of its capabilities, not only is you exhausting resources on your server, it's letting them waste your bandwidth, and it fills up your web logs with unnecessary 404 errors. So let's do something about that. We have to realize that normal users may trigger 404 pages too from time to time, so we need to account for that. But we can definitely detect if someone has caused X number of 404s in X seconds. Normally, if too many requests come in, we should be sending a 429 retry response to slow them down. And we really should play nice and support retry logic. But if we continue to see bad requests coming from bad actors, nothing says we have to continue to be nice. So once we get to some sort of internal threshold, like 10 bad requests in a row in 60 seconds, instead of sending 404 or 429 response codes, start sending back 200s with some random data in the body. Nothing slows down an attacker more than tons of false positives filling up their scanning logs. They will have to spend more time looking through all the results to figure out what's real and what's not. And if they're using automation, this could actually tar pit or even break their recon, making it much more difficult for them to continue on. And that's part of our strategy here with decoys and deception, to slow them down while giving us early warning that they're up to no good. There is a balancing act here though. More experienced hackers will themselves slow down the recon. Most recon tools support delayed requests, or they may be using distributed scanning, which makes this even harder to detect. And if your logic for monitoring such behaviors is too easy to trip up, nothing prevents them from sending valid requests every so often to restart your counter. But in most cases, for most attackers, this sort of tar pitting really does work and it slows them down. A lot of hackers are just too lazy and will move on if they keep getting too many false positives during enumeration. Sometimes, just the knowledge of deception technology being used will slow them down as they try to not trigger your defenses and figure out what's going on. And that's to your benefit as the defender. Okay, so we talked about leaving Honeytokens in your comments in your web pages, but why not in the JavaScript code as well? It's pretty common for hackers to try to strip out URLs from minified JavaScript code. If the URL looks enticing, they may even very well try to see what's there. So why not use that to our advantage? Add a code path that will never be reached that fetches fake content from an endpoint on your server. Monitor that endpoint and trigger an intrusion detection alert if it's ever called. Just make sure that the code path that this is in can never be reached by normal operations. You want to actually have this stored in code, as a URL stored in an unused variable can usually be detected by good source code scanners. But if, for example, you used a special parameter on a page that could theoretically trigger it, and that only calls to a dummy API endpoint that returns an empty array, the attacker is none the wiser, but you have evidence of their intrusion attempt. What's nice about this approach is that it's a high fidelity signal that a human has reverse engineered the code logic and has deconstructed your JavaScript enough to want to build an API request. And of course, it gives your ops team an early warning signal of an exploitation attempt. Since we're talking about JavaScript, I have another deceptive technique I want you to consider. If you have a popular web app that might be used in a phishing attack, consider monitoring for the homepage or login page being cloned. Add some obfuscated JavaScript that will call home and alert if that code block is ever run on a domain other than your own. Something like this will work. If this code runs on your server, nothing happens. But if it ever runs on another server that you don't control, you get notified of exactly where it's being hosted. This can really help your ops team to quickly detect malicious pages pretending to be your app during incident response. Okay, now I want to shift a bit to post-exploitation. No matter how good your security engineering is, there may be times where a vulnerability in your app may lead an attacker to gain a foothold into your apps and infrastructure. This is a perfect time for breach detection logic that can help aid your ops team to react exactly where the attackers are. Let me give you a few examples of things you can do. If you're deploying .NET applications, consider binding into your resource bundles a Honeytoken URL. If this is ever triggered, you can assume an attacker has found a local file inclusion vulnerability and has allowed them to download your packaged app binary DLLs, have decompiled it into source code, and is attempting to access extracted URLs that are not publicly known. Another example is by leaving around what seems to be sensitive PDF or Word documents in the application directory that can beacon home and let you know that they've stolen it. Let me show you an example of how you can weaponize a fake admin guide and have it call home when it detonates. Okay, to show you how you can create a deceptive file, I'm just going to use a simple Word document here. So, let's say we're creating the Contoso admin guide, and you can make this look as real as you want. There's no reason not to. But in our case here, this isn't really about the doc itself. It's about booby trapping it so that it'll call home whenever it's accessed. So if we were to go down into the footer as an example, we can insert a field. And we could look for a file called insert picture. And this gives us the ability to put a URL. In this case, you could put the URL of your application in a specific path that only you would see and you could track. In my case here, just because I'm going to test this locally, I'm going to use my local IP address. And I'm going to send it to a /admin guide. And I'm going to set this field to say that the data itself is not stored with this document. I'll hit OK, and of course it can't fetch it right now because I don't actually have an app or a server there. And I'm just going to make this as small as I can. And you can go even further and look into the XML and actually hide that so you can't see it. But at this point now, anytime this document is opened, it will go fetch that URL. So I'm just going to save this. And I'm going to call this Contoso admin guide. Sounds good. And I'll save it to my desktop. We'll close it. And I'll just drag it over from my other monitor. And now, if I was to simply start up a local web server just to mimic this behavior, now anytime we see a request coming for that particular URL, we should see this. Now, of course, we'll get a 404 because there's no real app here. But the point is to show you how it can beacon back to your application. So if someone opens up the application, or in this case opens up the document that's booby-trapped, it will detonate. And if we just go back we can see it's being called. So if you place these type of documents in your app root, and then you start seeing this getting pulled out from external locations, you know people have been able to access files within your application, and it's probably something you need to go look deeper into. What's nice about Honeytoken files like this is that attribution can usually be more closely tied to the attacker's actual location. If they download the admin guide and open it on their desktop, the file beaconed back to your server most likely will be from where they're actually opening the file, instead of from a VPN, proxy, or Tor exit node that they probably used when they were attacking your web app directly and stealing the file. This will help your ops team to more closely tie in events as they happen and allow them to build an incident timeline that may link various security events into a single attack chain. Oh, and remember earlier when I was discussing using decoy disallow directives in your robots.txt? Here is where you can combine deceptive techniques for maximum impact. Create a decoy support or admin page that includes a download of your beaconing document. If it looks realistic, they may take the bait and help your ops team with even more attribution by linking malicious activities together, from going to a page they weren't supposed to downloading a file they weren't supposed to opening it on their own machine when they're not supposed to. Luckily, we aren't malicious people here, but imagine what we could do. There are lots of other file-based examples like fake.bash history files, web caches, and bookmarks, but I'll leave that for you to investigate. And quite frankly, except for maybe fake files in containers, most of these techniques are better handled by your ops group who have physical control over the production infrastructure. And it's beyond the cadence of your app dev anyways. You can have a lot of fun with this, but our goal is to get high fidelity signals to your ops group that attackers are trying to breach our apps. We want this to be stable, clean, and concise. So focus on your app and what it's actually doing and not the infrastructure underneath it. So if you look at all the annual breach reports from companies like Verizon or Symantec, they always discuss how initial compromise is most easily done through credential theft or credential stuffing. Basically, attackers try everything they can do to gain unauthorized access using an authorized account. With so many massive data leaks these days, it's a great source for creds that our adversaries try to use with some of their password spray attacks. They'll usually try to target those of your users that have passwords found from other sites. So let's take advantage of this tactic so we can gain some useful threat intelligence. Combine this with other deceptive techniques to make a realistic attack surface. Maybe take a decoy admin login page published in your robots.txt and collect all username and password combinations fired at it. You already know it's suspicious behavior, but now you can link their activity to see if the attacker has any real account names and possibly even passwords. Your ops team will appreciate this sort of intel as it helps them zoom into which accounts are trying to be compromised. Another way to use deceptive accounts is through the honey user. You can stage accounts that have no actual access and watch if they're ever used for login. As an example, you could expose a database user in a configuration file, and if you ever see a login attempt with that account, to immediately trigger an intrusion detection alert. If you're using Active Directory, you can also use the same kind of thing with Honey admin accounts and disable all login hours for it. So even if an attacker has seen an account or a service principal, if they try to use it in any way, they will trigger a login audit event, which the ops team can immediately flag in their security monitoring system. Watching for Honey user accounts is a great way to detect a breach into your apps and infrastructure. From an attacker's perspective, if they happen to find any sort of SQL injection vulnerabilities in your app, they're going to have a field day extracting sensitive information from your database. Hacker tools like SQL Map exist specifically to allow attackers to easily exploit and exfiltrate data from your databases. They do this by fingerprinting your tables, columns, and views in an effort to detect interesting data and then dump and extract records through those same SQL injection flaws. So let's take advantage of this technique. I call this approach trap tables. Set up an attractive table or view that includes columns representing important data that is just too attractive for an attacker. Then alter that view to call a function on a select query to it. In other words, when an attacker tries to select any data from the trap table, it will immediately call a function inside the database. In that function, have it log the suspicious behavior and any user information, or better yet, have it call back to your application so you can consume the event and alert it through your security logging. This way, you can notify your ops team immediately of an intrusion into your app's data store. One word of caution though, things like maintenance and backup processes could touch these trap tables too, so make sure you account for that so you don't trigger any false positives. No one wants to be woken up at 2 in the morning due to a security alert to a compromised database, only to find out it's the weekly full backup running. Let me show you what a trap table might look like. As you can see, it's pretty trivial to set up a trap table as a honey token. It's an awesome indicator of compromise. You really should consider using it. So last but certainly not least is around deceptive data. So this last bit of deception will take a bit more work, but it has a high level of success in being able to pinpoint intrusions to your apps. If you have middleware or database proxies in your app that handles all your data, consider monitoring for poisoned records. These are bits of information in your data store that should never be touched or brought through your application. Maybe this is data actually in your trap tables, or it could be valid data coming back from sensitive tables. A poison record sits quietly in your database and should not be queried by legitimate users. One example might be to have a special permissions column in your users table. If you know your select statements never bring that column back, watching for whenever it does could be an instant alarm of suspicious behavior. Think of it as a data loss prevention guardrail. You could even decide to block the data from getting back to the user if this DLB fingerprint is ever detected. You are only limited by your imagination on ways to handle this. Just remember to watch for false positives. A junior developer who is used to doing a select star on a query could just as easily trip this up. Since I'm talking about developers, this is also a great source of deceptive data I'd like to cover. And that is doc endpointing with the likes of WSDL, MEX, and Swagger. These are living endpoints that describe web services and API endpoints. By their very nature, they document how to interact with your app. And you can easily insert a decoy function that attracts attackers to waste time trying to use it. Make it even harder for them and have it actually return something that seems legit to help them to go down the rabbit hole even further. Here's an example I once used that pinpointed a live threat actor going after one of our systems. What was interesting is we were returning what seemed like a real jot, and we could see exactly how they were trying to use it to access another customer's account. Knowing what they were going after, the ops team had enough threat intelligence to notify the affected customer and allow them to look inside their own organization about a breach that we've detected on their behalf. It was quite eye-opening for them when they found out a competitor was trying to log in as them.
It's a trap!
So we've covered 10 different deceptive techniques that you can use to help slow down your adversaries and give the advantage back to you on defense. Using decoys and deception helps to give you operational insights into suspicious behaviors to your apps much earlier in the attack chain, and empowers your ops team to get the right signals at the right time to be forearmed and forewarned. It also tarpits your attackers as it slows down their recon and exploitation methodologies, even if they don't realize that there are defenses deployed. Weaponizing honey tokens in this way allows you to set up tripwires, and when detonated, gives you and your ops team enriched security events timeline with possibly more attribution than ever before. This means indicators of compromise are more clear, and you can focus on the areas of your apps and infrastructure that show as being weaker. Honey tokens are inexpensive to deploy and maintain and give some of the highest fidelity signals you could ever have for breach detection. I highly recommend that you consider using them. And with that, let's take this discussion to the chat. I'd be happy to answer any questions that you have on the topic. Thanks for watching.